long-term system planning. Respected sir is the lead behind India's first of its kind MTech program on power system management. Thank you, sir, for joining us. With this brief introduction, may I request Dr. Bhakar, sir, to please enlighten us with his research expertise and the knowledge. Over to you, sir.
Thank you, Vikas. Thank you, JLCRC family, for inviting me. It's a pleasure to share the knowledge that we work upon with a wider audience that gives us inputs as well as benefits of interacting with people who are interested in that research, gives us significant inputs on how we can also shape up our research. So it's always a pleasure for us to just. Is my screen visible or?
Yes, sir.
Okay.
Sir, it is in PPT mode.
Yeah, I'm just.
Yes, sir. Now it's visible.
Yeah. Primarily, we come from a power systems background. However, over a period of time, more and more interdisciplinary research is being conducted, and that leads us into this FDP. Energy, as we all understand, is an important part of our lives, and the importance of energy as a source, it will continue to increase over a period of time. That we all understand, and specifically in the schemata of cities, urban areas, the role of electricity, the role of energy will continue to increase over a period of time. We are looking forward to significant urbanization of the systems. So we see more and more urbanization, people shifting from rural areas to urban areas, more and more industrialization happening. That is where the stress of the government is, and more digitization happening. All these three pillars, they reflect a significant level of, they reflect what is happening on the ground as of now. All these three schemas where government is putting in a lot of money, even private investors, they are coming in. So we are able to see significant technology adoption in these areas. Urbanization, as we all see, we see a significant number of people shifting from rural areas. We see a larger population would be there in the urban areas over a period of time. Digitization, adoption of digital technologies, wireless technologies, IoTs, and the other things associated with them. These are helpful, and these would continue to support the scheme of things that we are trying to develop. So we have got 5G technologies, we have got IoTs, we have got smart grids, we have got sensors, and all those things that can help us. So all these things, they not only make our lives comfortable, but also they help us to transform to a new level where we can enjoy the benefit of those technologies. Industrialization, as we all understand, as a nation, we attempt to be more industrialized. Our GDP should be more and more dependent upon industry output, industry growth. We intend to shift from a predominantly agriculture economy to an industrial and a scientific and knowledge-based economy. That would require significant energy consumption, and this would reflect obviously it would require significant energy resources. As we are shifting to these things, the requirement of energy would continue to increase, as well as the way by which we are sourcing this energy, especially in the urban area, that would significantly change. And along with that, how the technology, how the sensor technology and how the wireless technologies and all other technologies that we develop on the communication side, how they would be required for development of these systems. This is something that I would be focusing upon today. So we all understand we are going more and more electric. We are the way by which we consume our energy, whether it is transportation, where we have got a lot of electric vehicles, electric cars, electric buses, electric scooters, electric trains, and also coming up are electric aeroplanes and ships as well. This is one segment of transportation. Apart from that, other sectors, the requirement of heating and cooling in our systems, that is significantly increasing. The requirement, the other requirements, maybe in cooking, over a period of time, we'll see more and more cooking happening on electricity rather than happening on gas or any other fuel resources. So that all would continue to drive the increase in electricity demand. This, obviously, as we all understand, we generally understand these things, that this electricity is not being supplied only by traditional large power plants. This is over a period of time, it is shifting from centrally large station power plants to smaller power plants, to power plants at our rooftops, to small wind turbines, and so many other resources, even electric vehicles. They are being deemed to be sources of providing energy when they don't require that. So all these things which are likely to be sources of energy are primarily, if we see, they are distributed in the system. So we see that it is more distributed as of now. So rather than having them as concentrated power plants, now we would having smaller power plants at at our own locations. And instead of being only consumers of those electricity, we would typically, we call ourselves as prosumers of electricity. I have a rooftop on my household, and I not only generate for myself, I can also inject into the grid. So every household becomes a energy source provider. So these energy source providers, whether it is in terms of rooftop, in terms of microgrids, they help the users to produce their own electricity. And obviously that is quite cheap as compared to the grid electricity that we are consuming, to produce their own electricity and even to supply it to the grid as and when required. Obviously, this is more efficient because you are generating at the same point of time, at the same place, and you are consuming at the same place. So the requirement for network, that reduces. The losses that would happen in the network, they would significantly reduce. So obviously, efficiency is one of the basic key requirements in our systems. So we continue to look at systems in which development of those systems wherein we can improve the efficiency of the systems. We can improve the way by which we are using this electricity, whether it is in data centers, whether it is in households, whether it is in transportation, whichever way. Obviously, the aim to have minimal impact on the environment, that would always be there, because we cannot continue increasing our consumption without overlooking what is the impact that it would have on the environment. As these resources, they become more and more distributed, and as we are looking for better adoption of technologies, these devices, these systems, these households, they are getting more and more interconnected. So when we used to have central power stations, the level of interconnection, the level of interaction that we were having with those power plants, that was limited. However, as of now, we see that when we have got a solar rooftop, we can easily see on our mobiles how much generation it is doing. When we have an electric vehicle, we can see the state of charge of batteries. And even there are devices by which we can use our mobile and switch on the air conditioner at our home. We have got devices like Alexa and others, which can help us to control devices at our household. So as our energy consumption is increasing, the interconnections that they are having with the system, the way by which we are using them and way by which we are generating them, they are getting more and more distributed. They are getting more and more interconnected into the system. So that requires significant level of technology adoption so that appropriate communication mechanisms can be developed in these systems. These, not only IoTs, there are so many other ways by which we are connecting these systems to our main grid. We are connecting these systems to different applications that we are using. So is the requirement to develop all these scheme of things. This eventually leads us to the the theme of this lecture, which we call as the smart cities and the adoption of those new technologies for smart cities, the impact that these technologies would have on a wider spectrum of things, from all spectrums, whether it is the change in the way by which the industry is would be utilized, industry would be using those technologies, industry would be getting connected, the environmental issues, they would be more monitored. Security would become an important issue for smart cities, because obviously as the level of efficiency increases, people want to be more and more secure. Sorry. The retail mechanisms that are being adopted in the market, they would change. The society as such would be more and more interconnected. We would have these mobiles and other devices, handheld devices, which interconnect at all points of time to the system. The healthcare systems, the monitoring of our healthcare, that would become more and more monitored at any given point of time. Similarly, the houses in which we live, they would be smart houses, better energy management systems. The way by which we are transferring and producing energy, they would change. We are producing locally generated electricity. Locally, the consumer is producing it, and it can be utilized at the same place itself. Mobility in terms of whether it is public transport or private transport, the mechanisms of public and private transport, they would significantly change in these scheme of things, in this smart city environment that we are talking about. This, if you see, this brings us to a level, when we talk about smart cities, this brings us to a place where we see changes happening in all spectrums of our lives. This requires, in fact, while we were working on some of the technologies that we felt are in our domain, we realized that they have wider applications when we are working with people, let's say with civil engineers or architects, or even transportation engineers. We realize that the adoption of those technologies is more important. Interdisciplinary research and interdisciplinary development of mechanisms is important from the industry perspective. So when we talk about smart cities, it is not a domain in itself, but yes, it brings in people from all domains to contribute towards its growth. It is not a phenomena that is only in research. It is a phenomena widely adopted internationally. Smart cities internationally also, people have been talking about. There are global smart city alliances. All professional bodies, they have their own chapters and industry interaction platforms where they talk about smart cities. Smart cities as a whole, as a broader concept, it does talk about equity, providing equitable resources to all stakeholders in those cities, inclusive for everybody, the impact, the social impact that it would have for those who are the marginalized people, marginalized citizens of the society. It would empower them to utilize the benefit of those technologies and services that the government wants to provide them. However, with this, when we try to create these smart cities, privacy is obviously an issue because more and more things are getting, the information is getting transferred over the network. So as a user, as a citizen, I'm always concerned about the privacy of the data that is being transferred over the system. So also transparency about how the system is working, how people are using my data, how people are using the information that I'm providing. Understanding of that, maintaining that transparency is an equally important part in this scheme of things. Security and resilience. Security means being a part of that from all perspectives, whether it is from general security to cyber security. When we are creating these things, quite often people talk about that when we are using digital devices, when we are using smart devices, somebody is able to monitor my behavior, my response to the system, my utilization of the system. So that creates a concern for the citizens that whether I'm secure or not, whether I'm being observed at any point of time or not. So the privacy and cyber security, they go hand in hand. People want those that safety, that I'm secure at all points of time. Apart from that, whatever systems we are developing, they have to be sustainable. both from the operational as well as the financial perspective. So that requires significant investment from the government as well as participation from economic participation from the users. So there would be appropriate economic systems. That also is an important part, because we cannot have smart cities without people paying for that. And those who are utilizing those systems more, those who are significantly dependent upon the mechanisms that are being developed, they should be paying for those as well. Otherwise, creating a financially sustainable model for these smart cities, that would not be there. So not only is operational sustainability important, financial sustainability of these cities is equally important. So appropriate market models have to be developed by which people can pay for the services that they are getting. Apart from that, openness and interoperability, they are issues when we talk about the data, when we talk about the communication mechanism that have been developed. Interoperability, because these systems are not developed at a single point of time, they develop over a period of time. So whatever mechanism, whatever system I have installed today, that should be, if some other party joins in, maybe at a later stage of time, it should be interoperable with other systems developed at a later stage of time. So that requires significant interaction between what different people from different background, when they sit together, people from civil engineering, from communication, from sensor side, from architecture side, from planners to people like us who are coming from the power system background. They need to sit together and see to it that whatever systems we develop, they have these perspectives, these characteristics in the smart cities at least. In India also, we are not left behind. We started in somewhere in 2015. We had several rounds. Several cities were selected as smart cities as a part of the smart city mission of the government of India. It was primarily focusing upon the communities, the cities, development of communities as a part of the city environment. That is the core of the smart city environment. So this, whatever we do, we have to take into care that the last citizen that is there in the system, the community as a whole, benefits from whatever systems we are planning. It should be able to provide more from less. So whatever investment we make, it should be able to provide wider benefit. It has to develop on cooperative federalism. So all the cities that were selected, they were selected through some competition, some rankings that they developed, and based upon those, these cities were developed. And now also every year we listen to those rankings. So it is always that it pushes the city administrators and the citizens of those cities to participate, to contribute to the growth. Otherwise, without being an inclusive participation, it becomes difficult for anybody to develop smart city systems. So we have other characteristics like sustainability, as we've already talked about, technology adoption, not as a means, but as a not as a goal, but as a means to benefit the society, and convergence of different sectors, whether it is financial convergence, whether it is convergence from environmental perspective, or different sectors like transportation, like water, and other services that the city administration is providing. This, obviously, in the case of India, it is being monitored by at the central level, by the government of India, at the state level, by the state government, as well as at the city level. So we see these smart city missions happening in Jaipur, in Ajmer, and there are city level advisory bodies as well, where a lot of people like us, they participate and contribute with our understanding of how things should be shaping up. As of now, in India, we have got 100 smart cities, and a significant population is being impacted. Significant investment is being done over a period of time. We see a lot of these smart city projects being launched, whether it is in transportation, roads, sanitation. A lot of these are happening. So there, while we see the development of these smart cities, we can understand what is happening at the international level, what is happening at the national level, and what is the technology that has to be adopted for the growth of these. Though I'll be touching upon the concept of smart cities, but since it is the overall course is on smart cities, I'll be touching upon less upon those, and I'll be focusing upon the technologies on the grid side that would be helpful. So I'll just float through this. I understand that many of you would have already discussed some of the parts, some of the speakers may have already discussed these issues. But just to maintain the flow, when we talk about smart cities, it has to be touching upon so many different things, whether it is healthcare, building, mobility, infrastructure, technology adoption. Energy becomes an important part of that. Citizens being smart, and governance and education. These are the few things that people have been pushing hard to develop. And we see some of these things we are somewhere down the line, we are touching upon these things in our day-to-day lives. We can see smart governance in form of different e-mitras and other digital kiosks that we see at different places, which are more and more helping us to get connected with the government. So also smart education, smart boards, and all these things getting implemented, and different education systems, smart healthcare systems, they are being adopted not only at the hospital levels, but even at the government level, where they are providing these ambulances and all those support infrastructure. They are getting more and more responsive by using these technologies. And so also you can see these things happening in all the verticals of the smart city. Some of the key focuses as citizens of this country that we see, they are about having reliable power supply, having environmentally conscious power supply, water supply, a good quality water supply, and a reliable power supply, transport mechanisms, city as well as intercity transport mechanisms. They are to evolve in a way by which people get seamless transport, whether they are using a bus or maybe a train or a metro or whatever public transport is available. That has to be interconnected and as efficient. So there are a lot of government initiatives. Even recently, last month itself, the government has launched a program in which they wanted to interconnect different transport mechanisms, so that once a person gets out of the train, he gets easily gets maybe a bus or a city transport where he can connect, where he can reach his destination in an easy way out. These we have seen along with this the development of broadband IT infrastructure that has significantly, the cables are being laid, and public administration that has become more responsive. They have become more approachable to a way, and access to public data that has to be provided. People want that whatever is public data, that should be available when the bus is coming, when the train would be coming. All those type of public data that would help citizens to utilize those systems, those public data should be more and more visible and accessible from the customer perspective. That eventually would lead to high quality of citizens, high quality of intellectual growth within the people, and the growth of local economy, and overall benefit of all people, all stakeholders associated with the system. Specifically talking about some of the verticals, one of the important part that we see is transportation, which many of us are using. So that relates to one of the things that we talk about is smart transportation, smart ticketing, signage, geo services. We are able to track when the public bus would come up at a specific location. All those things are slowly evolving. As we see on those metro stations, similar systems are being developed for city transport as well. Communication gateways for public safety, the surveillance mechanisms, the emergency services. You see those when you go over to highways, that you can see phone booths where you can connect with any emergency service provider, as well as those things, they are available on phone calls. So appropriate communication gateways by which, when the moment we call a service, it is available at our doorstep. So that sort of communication gateway needs to be developed, and that focus is obviously, it is happening. Development of public infrastructure, where people on a wider basis, they can use those communication gateways for utilizing different services. Smart well-being, that would relate to good healthcare, that would relate to specifically focusing upon the healthcare and the needs of elderly. That is what, as the population of this country becomes more and more aged, the requirement for smart well-being systems, that would also increase. Along with that, some of the areas that people from the energy perspective, people from the engineering perspective are significantly focusing upon are smart energy systems, or what we call as smart grids, wherein we see smart substations being laid. That is one of the key things that we can really see happening. We have seen a couple of times in the news, gas insulated substations. Even last month there was a news, there were compact smart substations being installed in this urban part of this Jaipur city, in this old part of this Jaipur city. These are the points where we can see the adoption of technology, the smart grid technologies, for the development of smart cities. So there is a role, as we talk about all other verticals, the role of smart grid, the role of energy as a component of smart city, that becomes equally visible to all of us. That requires smarter buildings. When we talk about smart buildings, it encompasses obviously all facets. It encompasses surveillance, it encompasses ease to access, it encompasses good energy management as well. So a lot of us have been talking about building management systems, which encompasses all these smart buildings, whatever facets we talk about. So building management systems as well as energy management systems for those smart buildings is what people have been working upon for over all these years. Smart water management systems in which people can monitor. We have seen adoption of these technologies. Even recently, we could hear the news of smart water meters being installed in areas like some of the areas in Jaipur city, like Jawahar Nagar, where they are installing smart water meters, which would definitely help us to understand what is the level of water consumption, making people sensitive to the requirement of the water systems, the water management of those systems. Along with that, smarter retail systems, wherein those services, they can be provided, whatever consumption services people are using, they can be provided to the customers, to the users at in a very easy way out. So development of smart retail in the system, smarter retail systems, that would also be there in the system. So when we talk about smart cities, obviously there is a significant role of ICT and IoT, the communication technologies as well as Internet of Things. These help to connect those various dots, connect the consumers, connect the service providers, connect the bulk service providers, whether it is from healthcare or energy or water, whatever services people are providing, the system is providing, the government is providing. Connecting those people, those nodes together is what is the role of ICT technologies and IoT technologies. So these, when we are adopting these technologies, apart from the technology part, possibly which a lot of the speakers have been talking about, when we see the overall schema of things, what as a general engineer I would be looking forward to, what is the overall scheme of things that I intend to develop when we talk about smart cities? One of the things that we need to understand is that we need to collect all the data. We need to collect whatever is happening in the system at all points of time. And that requires the smart sensors that we have been talking about in this course for over a couple of lectures. So we need all those smart sensors installed at all nodes in the system, wherein we can collect that information and process it at our end. The processing or the analysis of that data, that is to be done centrally. That gives an insight into what is happening in different parts of the city. What is happening on the road transport, what is happening in the buildings, what is happening in the water management system, what is happening at different services, healthcare and others, whether there is a let's say there is a transport, there's a jam, the police can monitor it, or whether there's an accident, maybe from the healthcare system, somebody can assess that situation. If there is a public healthcare issue, the healthcare systems, they can assess that situation using that data that they are collecting from smart sensors. And from the analysis of that data, passing on that information to the decision makers, that is communicating that information to the decision makers, that is important. So apart from collection, we need to analyze that data. We need to communicate the result of that analysis to the decision makers so that they can take appropriate action to improve the operation, to manage the assets, or to improve the quality of the services that are being provided. So there are 4 steps to provide the 4 components of development of any scheme of things for smart city development. ICT, we all understand it is an important part. It requires, that forms what is the communication backbone of smart cities. It is being developed upon different telecommunication, and computers are the nodes where we can communicate. These computers or mobile phones, these are the interface nodes that we are using. ICT as a backbone of the system, it helps us to provide quality services, improves the performance of those systems. We can monitor them on a real time, gives us interactivity. I can give my inputs, I can give my data, and I can get responses from those services. It helps me to optimize my behavior, as well as the system also responds to that, depending upon how much it is able to capture, and depending upon how good the systems have been evolved. This is what would provide the contact between the citizens and the city stakeholders. This, we generally, when we talk from the communication perspective, we require these ICT mechanisms for appropriate network management, because we have got multiple networks that we are handling. We have a water network, we have a transport network, we have an electricity network, and so many other networks over which the supplies are being supported. So whatever network we are developing, that should be automated and simplified, and that requires a strong ICT backbone on with it, integrated with it. Automatic security threat isolation, if there are any security issues, if there are any issues in the system, identification of those, and isolation and any remedy if it has to be taken up, that should be on an automatic basis. The systems that we develop, they should be robust and they should be scalable. Scalable, today we are developing for one part of the city, we should be able to develop it for the other part of the cities, as well as whatever basic smart city environment we are able to provide today. Possibly if we want to develop upon it, if we want to build upon it, the opportunities for that should be available in those on those systems. So this requires us to develop IoT enabled networks in which using internet, we are able to provide services to all those consumers who are using internet on their devices, whether it is mobile phone or computers or any other devices. As a component of smart cities, energy becomes an important part. What we would foresee in the upcoming future is that there would be smart grid operators. The present scheme of things in which the systems are relatively non-responsive, they are not able to observe what is happening in the system, that would go away. And that is happening in parts of this Jaipur city itself. In several parts of the city, smart meters are being installed. And these smart meters, once they are installed, once they get connected to the system, they would be able to relay your real-time consumption to the grid operator. So the grid operator or the utility that is providing electricity, it would have to be smarter to respond to those situations. Using those smart meters, you can, the grid operator or at present you can call it the JVVNL, it would be able to observe in which area electricity there is a fault, in which area the demand is increasing, in which area there is theft, or where if the demand is increasing, where do I need to lay more lines or put up new transformers. So all those things based upon these smart metering technologies and smart grid solutions that are evolving, that are being adopted, the grid operator would be in a position to handle the energy requirements of these urban cities in a more efficient and controllable way. Apart from that, generating mechanisms. This is an important part, because as we are using more and more rooftops, as we are using more and more electric vehicles, the way by which we are using them has to be quite efficient. It has to be integrated with the system, and the system operator, the grid operator, has to respond to the requirement. So on one side, when we are injecting a lot of electricity with the help of solar panels, the grid operator has to be sensitive that a lot of reverse power flow would be happening. So that requires smart metering devices, that requires better, in fact, a whole change in the protective devices. Earlier, the protective devices, they were framed in such a way that if there is any reverse power flow, they would trip the system. However, now once we have got the solar panels installed on our rooftop, there will be a significant reverse power flow happening from our rooftops. When we are not using it, that electricity has to go to the grid. Reverse power flow would definitely happen. So with that, the grid operator has to be more, the protective devices that are there, the sensors that are there, they have to be more responsive to those situations in which reverse power flow can also happen. Or for that matter, if there are any other changes happening, the grid operator has to respond to those. This, the change in scenario is likely, even that the integration of electric vehicles, if you allow significant penetration of electric vehicles, which is likely to happen over the next few years, there has to be appropriate planning for that. And luckily, if you see, in the case of Jaipur, the Jaipur Development Authority, it has already floated tenders for optimal location of those charging stations, so that the system, the grid, does not burden with unplanned charging stations in the city. That is required, because if you do not do that, people would have charging stations. If you see in the walled city, there are a lot of unauthorized charging stations where people are charging these e-rickshaws, and that has led to significant degradation of electricity services in the walled city. So we need to provide those, plan those smart charging stations. These are likely to come up over the next 2-3 years, and you will see a sea change happening in that segment. Apart from that, a lot of energy service providers, they would evolve as the industry, the power industry as a whole is changing. It is quite likely that the services, the energy services that we are getting only from the distribution company, they are quite likely to change, and we would have opportunities to get energy, secure energy, to buy energy from other energy service providers, those who would be providing energy services, those who would be providing electricity or other sources of energy, by different means, whether it is in the form of batteries or over the same network that we are using. Maybe there are likelihood that as the industry structure changes, the possibilities of that would increase. So also when we see renewables, a lot of thinking is going on, because renewables as such, they are not dispatchable, they are not controllable as such. So you cannot control how much any solar panel would generate at any given point of time. Whatever is the solar irradiation available today, there are clouds, so the solar irradiation is low, so we cannot generate electricity. Tomorrow, if there is a lot of sunshine, it would significantly generate a lot of electricity. However, if it is not controllable, it becomes a challenge for the grid operator. So there are talks about controlling and operating this renewable generation in a more sustainable way, more controllable way, so that they do not disturb the rest of the grid, they do not disturb the rest of the energy management system in these cities. For development of these smart buildings, smart homes, we have seen a lot of these devices coming up. Smart meters are one. These tabs on which we see those applications on energy management systems. We do have these websites where you can pay your electricity bills. But moving beyond that, possibly as smart meters are being installed. And some of you who would have already installed solar panels, you would have seen that whatever electricity is being generated on your solar panel, you can easily see on a mobile app. So similar applications are likely to evolve over a period of time when, as consumers, when dwellers living in the city buildings, they would be using these smart distribution panels, building management systems, energy management systems, better power meters, and so on. And within the houses, we'll have these houses more connected. Home automation would happen. We will be able to control. Some of us have explored those things. We are able to control the working of an air conditioner with the help of our mobile. From a faraway distance, we can operate that. So also, as these devices become more visible, more adaptable, we would have those things. We can use Alexa or those IoT devices that different companies are providing to control the lighting in our houses that you have already, some of you may have already seen those things. So those things would significantly evolve over a period of time. And adoption of those is likely to increase in the households that we are using. So you can see a lot of those technologies coming up, from switchgears to modular UPS to efficient busways, UPS lighting control, access control. Cooling devices is one, like the air conditioner. You can have intelligent air conditioners which you can control. You can have network connectivity and cable management systems. They are coming up, improved to provide those IoT services. Floors, rack systems, flexible air containment, improving the air quality in our households. Chillers are another equipment which are used for cooling. So they are also coming up in a big way, especially in the malls and larger buildings. They are coming up so that centralized cooling can be provided, and so on. So a lot of these devices are coming up, which are IoT connected devices and which are helping us to provide those services. So understanding of these devices, how they would be implemented in the systems, that is interesting. And some of the lectures on smart sensors, they would have possibly focused upon those devices. Moving ahead from that, coming to the energy perspective, what all changes are we likely to see when we talk about smart energy systems within the smart city environment? What all is likely to happen? There are a lot of things that are likely to change, whether it is from the technology side, whether it is from the market side, or whether it is from the engineering perspective as well. So I'll be touching upon few things that are happening. I've identified 5 important technologies or mechanisms, frameworks that are evolved, that are coming up. And a slight introduction to each of those would help us understand what all changes are happening from the energy perspective. One of the important changes that are likely being adopted is new electricity market design, in which we say that rather than electricity being sourced from the main grid operator, we would be in a position to buy electricity locally in the local market or from our neighbors. That provision is not there as of now. To create smarter cities, to utilize the generation that is happening on our rooftops, we need to create that market in which even if my neighbor is producing electricity, I can use that electricity when his requirement is not there. For that, you need to create an appropriate market, or you need to have a market design. That is one of the important domains that would evolve, which would require the application of ICT for enabling that market design. Another important issue is the DRs, the distributed energy resources, whether it is the solar panels or whether it is the electric vehicles, which can provide services, which can provide energy storage services. Utilization, efficient integration of those services with the grid would require significant application of ICT technologies. Apart from that, a new concept which we call as virtual energy storage systems that would form an integral part in which, rather than physical storage, as we have got, one of the ways we talk about is cloud storage, cloud systems we talk about. Moving beyond that as well, we have systems called virtual energy storage systems, which effectively do not have any physical storage, but have the capability to respond to the systems in such a way that they create an effect of storage systems. For a simple example, that at any given point of time, whenever there is a requirement, energy requirement in the grid, and there is sufficient supply is not available, it can ask consumers like me to shut down my requirement, such that the overall load on the system decreases. So effectively, I can behave as an energy storage system in which I reduce my energy consumption in response to economic signal, in response to a price signal, in response to some incentive that the grid operator is providing. So obviously that also requires appropriate communication mechanisms. Apart from that, an important focus is on development of net zero buildings. And in those net zero buildings, important focus is on integrated energy systems in which we integrate different energy vectors, whether it is the heating requirement, whether it is the cooling requirement, whether it is the gas requirement or the electricity requirement, integrating all those energy systems together to provide an efficient energy system for these buildings and for these cities. This is an important perspective that would possibly evolve in this country over the next decade or so. Presently, it is being adopted in countries where there is significant requirement of other energy sources like gas, like district heating, like other heating requirement is significantly there. They have been talking about integrated energy systems. And as in a country like ours, where cooling requirement is likely to increase, integrated energy systems are likely to play a major role in the development of efficient energy systems. And thereafter, we'll be looking at what is the role of smart grids and smart cities. Sorry. From all these initiatives, what we would target is a cleaner environment, more recycling, improved environment for all citizens in the city, lower energy consumptions, and obviously economic energy consumption for the benefit of the consumers. So when we talk about the first issue, that is the development of local electricity markets or local energy markets, people call it both ways. What we see presently is we have got a single supplier of electricity, and whose prices, they are static, they decide the prices, we consume the electricity and we pay our bills. We don't have an opportunity to buy power from any other source. We cannot go to any other electricity supplier. So the switching of consumers from one energy supplier to another energy supplier, that is limited. And whatever are the cost of these networks, significant high costs, they are being borne by the consumers, despite that they may not be using the network at that level. So effectively, all this relates to the prices, the tariff that we are paying for electricity, they are significantly high. We all understand that as of now, for people living in a city like Jaipur, we are paying electricity charges in the range of 8 rupees, 9 rupees, 10 rupees per unit, and they are likely to increase. Is that what is the cost of generation? Or is that what is the cost of transportation of electricity? Truly speaking, it is not. So when we are buying electricity, purchasing electricity from a monopolistic electricity service provider, which is charging us at a very high rate of, let's say, rupees 10 per unit, despite that the electricity that is being produced, it is produced somewhere in the range of 2 to 3 rupees per unit. What is the opportunity? What is the opportunity that can make a change in our systems? The opportunity is to create local generating stations like my rooftop, which I already have, and enabling me to sell that electricity, to generate more and sell that electricity to a nearby consumer at the rate at which I am producing, so that I can also make money, and the nearby consumer, he can also get cheaper electricity. That requires development of local electricity markets. So presently what is happening is, as a rooftop solar, I am producing electricity at 2 rupees, 3 rupees per unit. And as a household, when I'm consuming, or as an industry, when I'm consuming the same electricity, the prices are significantly higher as compared to the cost of generation. So what happens is, the grid is purchasing at a very low rate and selling it at a very high rate. It is multiple times of what the actual cost of generation is. So that creates an opportunity by which, that creates a possibility that if we create local markets for electricity, a person, rather than buying from the grid, can buy from a nearby consumer, his neighbor, at a cheaper rate, and enjoy the benefit of cheaper electricity rather than buying it from the grid. This is a new market design, and that requires significant understanding of how this market has to be developed. We have got two such market models. One of them we call as peer-to-peer local electricity markets, and there's another one we call as community-based markets. The benefit of local markets is that everybody can produce. So you can produce electricity, I can produce, everybody in the city can produce electricity. So everybody can be a generator. You need not have a large power plant to provide electricity. That helps me to produce electricity at a relatively cheaper cost, and the entry cost, that is the size of the power plant, the investment required to create that power plant, is very low. With as low investment as somewhere around 50,000-70,000, I can have a single 1 kilowatt rooftop installed on my house, and I can generate electricity. So the entry cost to enter this market is significantly low. And as individuals, as myself, as you, each one of us can create that business and compete with each other to provide that electricity. So that creates a lot of opportunity for each one of us to produce electricity. The challenge is to match that local generation and the local demand at any point of time. So that requires obviously investment on the grid infrastructure side. That requires appropriate market mechanisms to be developed. But yes, the opportunity is there. The opportunity to trade locally. So if you see the figure on the right hand side, you can see that if one is producing at one point of time, let's say I'm producing tomatoes, you need tomatoes, I can sell you tomatoes. You have produced some other agriculture commodity, you have excess of that, you can sell it to me when I need it. In the same way, electricity can also be traded between different consumers when either of the participants, either of the consumers is using it. So that helps us to reduce our electricity bills. Rather than buying at higher cost, we can buy it from the local neighbor who is producing at 3 rupees. And even if he sells us at maybe at a higher price, instead of 3 rupees, he's selling at 4 rupees, 5 rupees. I, as a consumer, am benefiting because I don't have to buy power at anything higher than 8 rupees. So I'm buying it at a price less than 8 rupees. And the producer, the solar rooftop owner, he is selling it at a lower rate, at a rate higher than what it is producing. He's producing at 3 rupees. Even if he's selling at 5 rupees, 6 rupees, he's making profit out of it. And I'm also getting cheaper electricity. So that becomes a win-win situation for both the participants in the grid. The two mechanisms, I'll be talking about those two mechanisms. Some of those, the mechanisms of peer-to-peer trading, they are inspired from the platforms like Uber and Airbnb. Some of us have at some point of time used these services, Uber, Ola, Airbnb, and we understand how these platforms work. So, and obviously they require internet and they require appropriate ICT technologies for being utilized and developed. These development of these markets as in the case of transportation services, in the case of Uber, and in the case of housing services like Airbnb, what is required in these in the development of these markets is a high level of heterogeneity, in which there are a wide variety of participants participating in these systems. So there would be small users, there would be large users, there would be users who would be using them at the night time, there would be users who would be using only the system at the peak demand time. So a high level of heterogeneity in these markets is required. So also we see for the transportation, we have a high level of heterogeneity. Some of the people need it during the evening hours, some use it during the morning hours, some use it during the night hours. So depending upon what my requirement is, there's an application, Uber, which can provide me those transportation services. Same is the case for Airbnb. Different type of houses are available, different type of requirements can be met. That helps them to provide flexible pricing mechanisms. Some of them using at the night time can be offered those services at a cheaper rate. When the demand is not there, the prices of those commodities would go down. When the demand is high, the prices would go up. That we have already observed in the case of Uber, Ola. Spot transactions, you book a service, you'll get a service. So spot transactions can happen. The same way, electricity also can be traded in local electricity markets if we develop an appropriate market mechanism for that. So all those distributed generation sources, instead of using central services, instead of using central services from the central grid, we can easily use local services, local service providers, and develop and utilize those services from the local service providers. But obviously that requires appropriate market design and appropriate ICT technologies for those. Just to give you a brief understanding of how these two platforms work and how are the energy platforms likely to work. If we have explored the market mechanisms of Uber and Airbnb, there's a difference. In the case of Uber, we search for the cab. We are able to see the cab. The prices are already fixed by the platform operator. So the Uber, the company Uber, it gives us a signal that if I book a cab, 185 rupees would be charged to me. What it does is it matches, and there is a driver who is available. So basically the prices are fixed by the operator. The Uber platform matches the demand. That is, I as a consumer, I need a cab. It matches the demand with the supplier, that is the cab provider. With a fixed set of prices, it charges its commission. And if the demand is high, what it does is it increases the prices. So when the demand is high, it increases the prices. The driver also benefits because he's getting higher charges for providing services during those hours. And as a consumer, I get a signal to utilize the system to the lowest possible extent if I want to minimize my charges. So that is the way by which Uber works. As compared to that, there's another platform which is more decentralized. We call it, we have seen it, Airbnb. Some of us may have already used it. Airbnb does not set the prices. It indicates the prices. It is something similar to Magic Bricks that we have used for searching houses. Magic Bricks, Airbnb, 99 Acres, and all these websites are primarily based upon a decentralized market platform in which every consumer can search for the requirement as per his, whatever is his own requirement, he can search for those characteristics. So if I want a 1 BHK house, I can search for 1 BHK. And there would be a wide variety of offers available on that platform. And those prices of those offers are set by individual suppliers, not by the platform. So if I have a house, I can offer it at a rent at 1,000 rupees. Somebody else may be offering at 2,000. Another one may be offering at 5,000. So depending upon what is the charges that I want to charge, a wide variety of offers will be available on that platform, which can be utilized by the consumers And there would be a wide variety of consumers. Somebody may require a cheaper housing opportunity. Somebody may be looking at luxurious housing opportunity. So depending upon what my requirement is, a wide variety of offers will be available. This is different from what Uber does. Uber sets the prices and it matches the demand and supply. Airbnb does not match the demand and supply. It only provides an efficient searching algorithm. But it gives customized prices. Like say, if I want to search from 1,000 rupees to 2,000 rupees, I'll get all those houses which are available in that range. So it customizes those pricing algorithms, which helps me to make a judgment. These two types of local energy markets, peer-to-peer market mechanisms exist. One is a centralized assignment mechanism, which primarily Uber, Ola, and other service providers use. And the other one is decentralized, which Airbnb uses. Both these you can see, and you have used the two types of services and benefit from those two types of services. And you understand how each one of those works. This is one sample by which you can understand how even electricity markets would evolve. And I can buy it over platforms like Uber or maybe like Airbnb. Both type of platforms are available, can be made available, can be developed. And as a household, as a consumer, I can buy whenever the local prices of electricity are low and the central prices are high. I can buy from local market, and whenever they are not available, I can possibly go back to the central market and buy from the central systems. This is what it would eventually look like, local electricity markets in which you can see these utilities providing electricity. There will be residents with solar panels. There will be some residents without any solar panels, some residents with solar panels and electric vehicles, some residents with only electric vehicles. And these utilities would be charging, as on date, they are charging them. So they are charging some tariff to the usual household resident owners, some tariff for the electric vehicle, the resident who is using electric vehicles, but it also offers a buyback rate. If this electric vehicle is providing reverse power flow, if it is the storage that is available in the electric vehicle, if it is able to provide reverse energy, then the utility may be paying for that. There may be households in which only electric vehicles are utilizing, so there will be specific tariff for them. There would be households which are with solar who would be supplying power back to the grid. They would not only have a tariff for consuming electricity, but some buyback rate at which the electricity would be injected to the grid. This is the present state of affairs that is happening. This limits the opportunity of trading between different peers, trading between different participants in the city. What is likely to happen tomorrow? These energy sources, they would be allowed to participate in a peer-to-peer market with another participant in the system, which have got electric vehicles. He may be using it. So rather than buying from the grid, he can buy from the nearby solar power plant, nearby my neighbor who has got a solar rooftop. And so also I may have people who may be using these rooftop as well as electric vehicles. So they may be able to trade with other participants, nearby participants. And there will be simple residents who would simply be using only consuming electricity. Either it comes from the grid, or it comes from the solar rooftop, or even if it is coming from the electric vehicle, those batteries of the electric vehicles. So any of these mechanisms can be, trading mechanisms can evolve in a local market. Development of these electricity markets, it is not simply we say a creation of a market and that can be evolved. What it requires is multiple infrastructure layers. One is a virtual layer in which all this information system, the market platform, the pricing mechanism and the energy management system that runs. Another is a physical layer in which the grid interconnection, the metering part, and the communication part that would be required. And then there are other stakeholders and regulators that will be in place. So even development of these markets, as you see in the case of Uber and Ola, they are relatively easy because the network in the case of transport and the case of electricity, they are slightly different. In the case of urban transport, you don't have toll roads. The city roads, you don't have to pay toll for those. Whereas in the case of electricity transport or energy transport, you have to pay for the grid infrastructure. And all electricity can only flow through the grid infrastructure. In the similar way as traffic can only flow on the roads, electricity can only flow on the grid infrastructure. So because of this, because of the limitation that these services can only be provided over a network, the market mechanisms have to evolve in such a way that they take care of the investment that are being made on the network side. In the case of city transport, we are paying city charges, we are paying urban tax, council tax, which effectively leaves, we don't face any situation in which we have to pay toll for traveling within the city. If we travel on the highways, obviously we are paying tolls, but within the city, we don't pay tolls. We are only paying taxes. Whereas in the case of electricity, the moment you get an electricity connection, you have to pay for the electricity network. So in that case, you have to take care of the grid infrastructure. You have to develop that grid infrastructure appropriately. You have to pay for that. And appropriate metering infrastructure has to be developed so that I can connect with the grid and I can pay for the connection, pay for the utilization that I'm doing. This is one part. On the virtual layer part, appropriate information system has to be evolved. Appropriate pricing mechanism has to be evolved so that the availability of that, whether the electricity is available, whether the cab is available, that I can easily see on my mobile. That is required. Appropriate pricing mechanisms, whether the cab is available at 185 rupees or 170 rupees if I want to use a two-wheeler from Ola or Uber, what are the charges available? So different type of services are available on those platforms. Similarly, different type of services would be available on these platforms as well. So they would require appropriate information systems to be developed. There are a wide variety of market mechanisms, as we discussed in the case of this Uber and Airbnb. A wide variety of trading platforms can be evolved. Some of them, we call them as community-based P2P, in which if you see the diagram A, there is a central service provider and multiple users are using those services in their own zones. So let's say in the case of an area like Malvinagar, you can have a central service provider who would be providing you a platform by which all people within that area can trade electricity. There could be another full P2P, and on the right hand side C, you see a hybrid P2P. There can be a full P2P in which anybody in the city can buy electricity from anyone else. That platform can also be created, or a hybrid of those two, in which there are local peers, local communities like Malvinagar, in which a large number of participates in the local market of Malvinagar, and Malvinagar as a whole participates with, let's say, Jagatpura, or it participates with C scheme. It trades with C scheme with whatever excess electricity it is available with itself. So both type of market platforms, they are possible in this scheme of things. The next thing that I think would become important from an energy perspective is the development of virtual energy storage systems. When we talk about virtual energy storage systems, the first thing that would come into our minds is the air conditioners, the washing machines, and any other cooling mechanisms that exist in our buildings, in our households. These are devices which can be used at different points of time and whose consumption can be shifted. Let's say, for example, during the day hours of 2 to 3 p.m. in a summer day, the requirement of electricity is too high. What it can do is, what an air conditioner can do is, you can cool that building prior to 2 p.m. and reduce your cooling requirement from 2 to 3 p.m. and sustain at a lower cooling period, lower cooling effort. The building is already cooled. It is thermostatically maintained. The temperature within that building is maintained because the heat loss would not, it has to be maintained in such a way that the heat loss is not so significant. And rather than utilizing the electricity, the cooling requirement between 2 to 3 p.m., you utilize it at a different point of time, cool the building, maintain it in a cooling level, and reduce your consumption during 2 to 3 p.m. when the system demand is high. So effectively, as a thermostatically controlled load, you can reduce the demand in the system and act as a storage system for the grid rather than acting as a demand during that grid. So that can effectively provide what we call as virtual storage systems. So the role of these cooling systems, thermostatically controlled loads, air conditioner is one. The other one is washing machine, which is not a cooling system, but obviously the utilization of that can be shifted. The charging of electric vehicles, that time can be shifted. So all these devices in which the utilization time can be shifted, they would significantly participate in the energy management systems in these cities and provide wider services in the form of, effectively in the form of energy storage systems. These can provide a wide variety of grid services. I will not be touching upon those. Another important aspect that would come up is the development of integrated energy systems. Presently, we are using electricity as one of the energy sources, which we are using for lighting, which we are using for cooling. We may use it for cooking, we may use it for charging, that is a transportation service. Apart from that, we are also using petrol and diesel for transportation. So we are using, some of us, in fact, every one of us are using gas as a source of energy. So wide variety of energy sources we are using. And in any urban environment where our energy consumption is very high, there's an opportunity to integrate all these energy systems into a single energy system so that all our requirements can be, whatever different sources which we are using, they can be integrated such that the moment a service is not available from one energy source, the same service can be provided from possibly another energy source. Some of the examples, easy examples that you see are cooling, heating, and electricity and energy storage. However, there are wider examples possible when we see the international spectrum. In our country, we don't have requirements, we don't have systems, strong systems in which gas supply is happening in the household. Some of the cities, they are developing, some of the big residential colonies, the big residential societies, they have got those gas transportation, gas pipelines, but most of the households, they are yet to come up. So one of the pipeline that comes up into our household is gas. Another network that is coming up to our household is electricity. In some of the countries where heating requirement is significant, the heating can also be done by way of oil heating. So there's another network of oil heating that also runs into that. And even gas can be utilized for heating of the households. So a couple of networks, they are flowing into the household. and the same household can be using electricity for heating. It can use gas for heating. It can use oil for heating. And depending upon which service is available, I can utilize that service at different points of time. However, if rather than having multiple networks of the same type of services, I require cooling services or I require heating services, I've got different networks providing that service. Rather than having those, if I integrate all those services, the benefit that I can draw having an integrated energy system, less network would be required, a more integrated energy system in which if the service is not available from one type of energy source, it can be made available from other type of energy source. That possibility can be created. And that is a likely possibility that would evolve in the urban systems that we are presently utilizing. So you would in your kitchen, you would have the first thing that you already have is you have a gas cylinder. Eventually, you would have a gas pipeline installed in your household, one network coming in. You have got electric points in your kitchen, which you can use for cooking. So for cooking, you can either use electricity or you can use gas to cook your food. What is likely to happen is that those two systems would be integrated at the back end. Maybe in the area, in the locality of Malvinagar or Pratapnagar, we have a central integrating system in which the excess gas can be utilized if the gas requirement is low. That can be utilized to produce electricity when the electricity requirement is more. Or for that matter, whenever significant electricity is available, let's say there is a sunny day, a lot of solar generation is happening, and we don't have that requirement of electricity. What can be done is that the same electricity can be utilized to produce gas, hydrogen from water. So excess of electricity can be used to produce gas, which can eventually be used to provide energy services. It can be stored, and that hydrogen can be used at a later stage. And whenever excess gas is available, that can be utilized to produce electricity or providing other energy services to the consumers. So integration of these services can help us to reduce the wastage. When, let's say, excess electricity is available, you can produce gas, or when excess gas is available, you can use it to produce electricity whenever the electricity demand is there, so that you don't have to put up new power plants. These integrated energy systems are likely to evolve over the next decade, in which integration of different energy vectors would happen. This would help us to reduce the impact on the environment, because if it is not available from one source, we'll be able to use it from other source, wherein otherwise it would have gone waste. So that philosophy can be used to utilize these energy systems. This is a likely reflection on integrated energy systems, which would help us to produce net zero buildings, because in our buildings we have got different energy requirements. In our cities we have got different energy requirements. What we are producing right now on the generation side, we have got the electricity grid, we have got the gas network, and we have got the heating or the cooling network, whichever way you call it. On the demand side, we have got the electricity demand, we have got the transport demand in terms of electric vehicles, we have got a cooling demand, which can be provided by gas cooling. We have a heating demand, which can be provided by a heating network, and a cooking demand, which can be provided by the gas network as of now. However, if we integrate it with the help of these integrators, what it can do: access of solar generation available at any point of time, it transforms it into gas and stores in the form of energy storage in the gas cylinders. We have got electric chillers, that is the cooling systems. They can provide the cooling, they do provide the cooling demand. However, whenever excess generation is available, it can super cool the cooling systems, that it can create more ice, and that ice can be stored for longer hours. Let's say during the night hours, a lot of wind is blowing, we don't have that demand. What do? We use that electricity to produce ice, which can be stored obviously, and the shelf life of ice is for a few hours. The same ice can be used during the daytime when there is a cooling requirement. So that is a form of storage that we can develop. Similarly, absorption chillers, which can store that cold stuff, the cold air or the coolness in those chillers, and those can be utilized at different points of time. We have got the gas boilers. We have got the gas boilers, which can use the gas. Whenever excess gas is available, it can transform that gas. Either it stores that gas, or the same gas can be used for cooling purposes, or it can be used for fulfilling the heating demand, or possibly, as I just said, you can store it. So that helps. This integration of different energy vectors can help us to store the energy vector which is available when it is not required, when the demand is low, or it can be utilized whenever the storage that has been developed, it can be utilized whenever the excess demand is available. The storage can be in the form of electricity being stored in form of batteries. It can be in the form of cooling storage, or in the form of heating storage. So wide variety of storage mechanisms, they are likely to evolve, and once they evolve, it is likely that we would be in a position to utilize these systems as integrated energy systems for developing net zero buildings. Effectively, the overall requirement from the grid that would significantly reduce. This leads us to a situation in which the variable demand that we have, the variable demand in our households, we have the demand that increases during the daytime, it is high during the morning hours, and it can go down during the night hours. Associated with that, we have got flexible loads. We can shift the consumption of our washing machine. We can shift the utilization of our air conditioners. Along with that, a lot of distributed generation coming up. So that distributed generation requiring a lot of ICT technologies to enable the markets for sharing of those resources, for trading of those resources on those mobile applications, on those ICT platforms, giving us easy access to the market in which we can access that energy in a smarter way is what is desired in the scheme of things. I understand I've taken a lot of time, and I'm open to questions right now, if there are any.
And dear participants, if you have any queries and any doubts, please raise hand or type in chat box. Sir, it was a very wonderful and informative session. Sir, I have a small doubt. In a slide of smart city concepts, there was a term called smart citizen. So in this regard, are we talking about the citizen with a smartphone or something more?
I think when we use the term smart citizen, it is not only using a smartphone that is the case. We are connected with various devices. It is in terms of smartphone, it is in terms of smart meters, and a wide variety of devices by which we are able to assess our consumption, assess the market prices. A smart citizen is not limited to a person who has got a mobile phone. It is a person who is responding to that. It is a person who sees that signal, takes that signal, that economic signal that the prices are going up or down, and responds to that situation either by a predefined algorithm or at any instant point, any way. So let's say I can define that whenever the prices of electricity are going high, some of the devices in my household, they would shut down.
Mm.
So let's say easily I can switch off my refrigerator at any point of time during the winter season. So I don't need it for the whole day. So a smart citizen would be one who is responding to that signal that is being provided, so that whatever investment that has been done, the benefit of that can only be derived when the citizen is smart. He responds to that situation. So the responsiveness of the customer or the citizen is what would make him smarter, making him helping him to take intelligent decisions in that system.
Sir. And sir, you also mentioned virtual energy storage in smart cities. Sir, is this technology started in some city around, or it is in its research phase?
It is effectively, when we say presently, we are in a very crude form. We have got our electric vehicles being there. Presently, what we think of electric vehicles is that we will plug in and use it to charge our batteries. That is the only thing that we have. Presently, in the case of our country, the provision to inject into the grid, that market mechanism is presently not there. In some of the countries where the markets, the electricity markets have developed, like in UK, like in US, they have got developed markets, they have aggregators. Aggregators are basically, you can say, middlemen who aggregates these services from a wider set of customers. He would do contracts with 1,000 customers, and whatever electricity they provide, he aggregates that, he meters that, and provides that to the grid or to any other consumer in the system. So that obviously requires that ICT infrastructure, that requires that metering infrastructure, that requires a proper market mechanism for that.
Yes, sir.
That is still missing in our country. In some of the countries, they have done it. And aggregators, the moment aggregators are available, those type of services are likely to come up. Presently, what we are looking at is the adoption of smart meters. Smart meters are being installed in our cities. Possibly some of our households we would have already installed.
Yes, sir. We are using. Yes, we are using.
Yeah. So as we move beyond that, as there's one electricity bill that is pending in the parliament right now. If that is passed, that would create opportunities for aggregators to participate in the market. That would create an opportunity wherein people can inject into the grid using these electric vehicles. Presently, our interaction with the grid is limited. I have a solar rooftop, I can inject into the grid. I have a net metering facility. That is all interaction that I'm able to do with the grid, apart from consuming electricity. The provision of virtual energy storage systems would come up when devices like electric vehicles either aggregating at my end, or let's say there are parking lots wherein 1,000 electric vehicles or 100 electric vehicles are getting connected. They can provide, the parking lots can provide those services to the grid by way of those batteries that are connected. So when 1,000 electric vehicles are connected to the system, possibly they can inject into the grid with those parking lot operators. Those two provisions are likely to happen.
Yes, sir. Yeah. Okay. Thank you, sir. It was very informative. Sir, now I would like to request all participants to switch on their videos so we can take a group photo of this session. So please switch on your videos. Thank you all. Now, on behalf of the EC department and the participants, I extend a very hearty thanks to the Honorable Rohit sir, who blessed us with his presence and took out the valuable time of his busy schedule. Respected sir, I especially liked your speech where you mentioned smart grid operators, smart generators, and renewable operator and virtual energy storage system. The way you explained the topic is exemplary. I must mention your deep sense of appreciation for Dr. Rohit Bhakar for his work. Thank you so much, sir. Thank you very, very much.
Thank you for inviting me.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.
There is an announcement to all participants that session 2 of the FDP will start at 11 a.m. today.